Hello, ladies and gentlemen. Today we're going to talk about the angle measures of polygons. You're going to need your notebook or your notes, a foldable, a calculator, and something to write with. So let's get started. So for starters, let's review a little bit of the vocab. What it means to be concave versus convex. Okay, so concave, the word to me, cave, seems like it's going to cave in. So concave are going to be those figures that the lines go inside of the shape. Okay, so we kind of indent or we squeeze the shape a little bit so that there's a couple points on the inside of the shape. Whereas convex means that all of my points look to be on the outside of my shape. So another example of a convex would be if I were to draw, let's say, a pentagon, but I go like this. Again, since it's going into the shape, okay, if I can draw a line connected on the outside of the shape from two vertices, that means it would be a convex polygon. Again, here, I can draw a line from two vertices on the outside. Whereas on my convex ones, if I draw a line, all of my lines from each point would be on the inside of the shape. Because if I were to draw a line from these two vertices, it would be right on the edge of the shape. So again, a convex is like if we have something that goes inside of the shape, or I can draw a line from 2 points of the shape that would be on the exterior. Convex is when all of my lines that I draw from every single vertex or every single point of the shape would be on the inside of my shape. Another vocab word to review is what it means to be regular. So a regular polygon, and let's make sure that we jot this down. Regular polygon has all congruent sides and congruent angles. So equilateral and equiangular. All of the angles on the inside are going to be the same, and all of the side lengths are going to be the same. So, and also, if we were talking about polygon, poly is a word for many. So it just means many, and gon is what we use for shape. So many shapes. So a many-sided shape is what we would refer to as a polygon. So now this is just a couple of review words that we need to make sure we know for today's lesson. So again, remembering regular means congruent sides and congruent angles, and polygon is a many-sided shape. So this is a slide that I strictly just want you to watch and listen, okay? So this side we're going to talk about, we're going to kind of figure out where our next couple of theorems come from. So for starters, this first shape, this is called a trapezoid, and the number of sides we have are 4. So I'm going to write 4 in this box. The number of triangles I have now, I want to try and make different triangles inside of my shapes, but I don't want to overlap my triangles. I don't want any of my lines to overlap. So if I were to connect other vertices in here to make other triangles, I would overlap the line I've already drawn. So it looks like the most number of triangles I can have inside a four-sided shape would be 2. Now, the importance of getting triangles inside these shapes is now we know the degree measures because we know that there are 180 degrees in every triangle. So if I have 2 triangles, that means I would take 2 times 180. And if I take 2 times 180, that's going to give me 360. So what that means is in this four-sided shape, I have 360 degrees. Let's see what happens when I have a 5-sided shape. So here, my pentagon, I have a 5-sided shape. Let's see how many different triangles I can draw. I can draw this one. I can draw this one, but if I were to connect my other 2 vertices, again, I would cross those lines I've already drawn, so I don't want to do that. So it looks like I have 1, 2, 3 triangles. So I have 3 triangles, and again, every triangle has 180 degrees, so I'm going to take 3 times 180. If I type that into my calculator, 3 times 180, I am going to get 540 degrees. Okay, let's see what happens when I have 6 sides. So in this hexagon, again, I have 6 sides. So let's see how many triangles I can make. I can make 1 triangle. I can make 2 triangles. I can make 3 triangles. But if I were to connect any other vertices, I would overlap the lines I've already drawn. And I don't want to do that. I'm going to start at 1 vertex and I'm going to make as many triangles from that vertex as I can. So here it looks like I have 4 triangles. So then I'm going to take 4 times 180, which if I type that into my calculator, 4 times 180 is 720. So let's skip 7 and just strictly move on to 8 here. So I've got 8 sides. Let's see how many triangles I can draw. 1, 2, 3, 4, 5, 6, because that one will give me 2. So 1, 2, 3, 4, 5, and 6. So then I have 6 triangles. So then I'm going to take 6 times 180, and that's going to equal 1080 degrees. Okay, so now are we seeing a pattern? Is there a pattern from this 4-sided shape and the triangles that correlate with it? Look at here, 4 to 2, there's a 2 space difference. 5 to 3, 2 difference. 6 to 4, 2 difference. 8 to 6, 2 difference. So in this next slide, we're going to compose a formula. Or right now, if we wanted to compose a formula, it looks like I'm taking the number of sides, so we'll say that's n. I'm subtracting 2, and this is how I would get the number of triangles. But then in order to get my total degree measure, I'd have to take that times 180. So on the next slide, we are going to come up with these different formulas. And like I said, this last one that the sum of the interior angles. So the interior angles, that's just going to mean inside. So the measures on the inside are going to add up to n minus 2 times 180. And you can write that as 180 times n minus 2 if you'd like. Either or, they mean the same thing. So now when I'm talking about a regular polygon, in order to derive the number or the angles, we know that all the angles have to be the same. So again, my formula is still going to be n minus 2 times 180. But I know that every single angle inside, let's use a square for example, I know that all of these angles have to be the same. Now a square is a 4-sided shape, so that means I should have 4 angles. So however many sides I have that many angles. So if I had to split up this 360 degrees, I'd have to split it up by 4. So I would divide by 4. So likewise, if I'm making a generic formula, we're going to divide by the number of sides. So again, this is the equation that I'm using if I have a regular polygon. N minus 2 times 180 divided by n, because I'm trying to figure out what each interior angle is, not just the sum of the interior angles, but what each interior angle is. Now for exterior angles, if I were to draw, let's say, a octagon, it's not going to be the best one, but here, if I were to draw an octagon and I were to calculate the degrees on the outside. Now all of the degrees on the outside makes a circle, and if we remember way back when, how many degrees are in a circle? There's 360. So the angles on the outside of any shape, if I were to draw a square, a rectangle, a triangle, the angles, if you add all of them up, are always going to equal 360 degrees. Always. No matter what type of polygon I have, it's always going to equal 360 degrees. But now if I have a regular polygon, that means all of those exterior angles must be the same. So that means I'm going to take that 360 and I'm going to divide by however many angles I have. So again, the exterior angles are always going to equal 360 degrees. And if I have a regular polygon, that means all my angles have to be the same. Even if they're on the outside, they still have to be the same. So I'm going to take that total, which is 360 always, and divide it by my total number of sides. Now, if you need to make a mental note, just to remind yourself that n equals number of sides. So jot that down if you need to. All right, so let's talk about a couple of examples. Now, there's many different places you can write these examples. You can write them on the paper that is in your notebook, right next to where you would put your foldable. Or you can also flip the foldable open, and on the top part of the flap where there is no writing, you could put the examples. Now, I want to remind you that there are going to be 4 total examples, so to make sure that you write or leave space for all four. So let's get started here with this example. And the first thing I want to figure out is I want to break down these words. Okay, so here I have sum, and I'm talking about the interior angles of a convex. And remember, convex means it's not caving in. All the outsides are on the outside of the shape. So if I'm talking about the sum, and I refer back to those four different equations, four different formulas that we wrote down on the previous slide. If you have your foldable open, you should be able to refer to them. Find the sum of the interior angles. So if I'm talking about the interior angles, that must mean that I have to be on the left-hand side, because those are the two formulas I have when I'm talking about interior angles. Okay, now when I'm talking about the sum means the total of all the angles. So if I look there, I have the sum of the interior angles of a convex polygon, and I have each interior angle of a regular polygon. Now, nowhere was I told that it's a regular polygon, so I'm automatically crossing off that formula. The only thing I would be left with is the formula that is n minus 2 times 180. So if I'm talking about this formula, now I got to understand what n means. N just means number of sides. So if I go over here, a 30gon, that's telling me that it's a really big polygon, but it must mean I have 30 sides. So I'm going to go back over my formula. I'm going to punch in 30 for n. 30 minus 2 times 180. Now 30 minus 2, we could do this in our heads, so that would be 28, but 28 times 180, I probably want to type that into my calculator. If I type that into my calculator, the answer I would get back would be 5,040 degrees. And I have to put degrees because I was trying to find the interior angles. So that's why I would have to label that with degrees. Now, if you forgot your degrees, make sure you put that in, because Miss Kessler will dock you without labeling them. Let's move on to example 2. In example 2, it wants us to find the measure of an exterior angle. So now if I'm talking exterior, that means I'm going to the right side of my foldable, because that's the part that is talking about exterior angle of a regular convex polygon. Find the measure of n exterior. So n just means 1. So if I look here, I have two different. I have the sum of the exterior angle, which is always 360, or I have each exterior angle of a regular polygon. So again, I am talking about a regular here because I used that vocab, regular. So I would want to use that formula. So that formula tells me that I take the total, which is always 360, and I divide it by my number of sides. So again, every single polygon has a total of 360 degrees, but the number of sides is going to change. Well, now I have a decagon. Well, what does decagon mean? Again, this is a vocab word we might have not touched on. If you needed to Google it, you could use your resources and Google what decagon means. But decagon is the term we use when a polygon has 10 sides. So the n value is going to become 10 here. So when I take 360 and I divide that by 10 in my calculator, or even in my head, I'm going to get back an answer of 36. Again, since I'm talking about angles, we better make sure to put that degree sign on there. So if you have any questions, make sure you jot those down, put question marks by this example so we can discuss them in class. All right, so we're going to start with our next two examples then. In example 3 and in example 4, again, making sure that you write down the wording of these examples so that when you do your homework, you know exactly where to look. If you just write down the work, you might get confused on what that means. So write down the words so that you know exactly what types of examples we've gone through. So in example 3, the measure of an interior angle of a regular convex polygon is 108 degrees. We need to find the number of sides. This is where it gets confusing because in my formulas, I've only been finding angles now, but now I want to find the number of sides. So I got to know that the number of sides is just referring to as n. So again, let's look here and determine which formula we're going to help. So of n interior angle, that means 1. Interior means I'm going to be on the left side of my foldable. And now I am down to 2 choices. And now I realize it says regular. So regular jumps me down to 1. If we were to write down each interior angle of a regular polygon is going to equal n minus 2 times 180, right? So I'm going to write n minus 2 times 180 all over n. Now the reason I write this inside parentheses is so that we know that that 180 has to get distributed to both, because when I wrote it the other way in my notes, 180 times n minus 2, I had to distribute it there. So it's no different from the other way. So we're still going to have that n minus 2 in parentheses. And this is the formula I'm using to help me solve this. But now the n is the unknown. I don't know, because here in this example, I told you that the measure, this formula, what it's helping us find is the interior angle of a regular polygon. A regular polygon is 108. So we know that every angle inside that polygon is 108 degrees. This formula doesn't help us here because we don't know the number of sides. It helps me to find the number of sides because I already know that every interior angle in this polygon, however many sides it has to be 108. So can I figure out how to solve for n here? This goes back to helping us, can we realize, or how do I determine how to solve this problem? Could I maybe put 108 over 1 and then cross multiply? Absolutely we can. So when I do that, I get 108. Sorry, I was going to write 8 too soon. 108n equals n minus 2, again in parentheses, times 180. So this tells me then I have to distribute that 180 to both. So I'm going to get 108n equals 180n minus 360. So now it becomes a problem where I just need to solve for n. So I'm going to subtract 180n from both sides. Over here, I'm going to get negative 72n equals negative 360. Divide both sides by negative 72. And I'm going to get n equals, if I type that into my calculator, hopefully we realize that negatives cancel each other. We should get back a positive 5. So this tells me that I have 5 sides. When I have 5 sides and a regular convex polygon, every single angle inside those pentagons are going to be 108 degrees. So that works every single time when I have a regular 5-sided polygon. Let's see if we can figure out example 4. So in example 4, we need to find the measure of the interior and exterior angles of an 18-gon convex regular polygon. So that means we have a regular polygon, but I need to find interior and exterior angles. So that means I'm going to use the bottom formulas in both situations. So n minus 2 times 180 all over n. Now what this means is since I have 18 and it's regular, that's how I knew which equation I was going to find. So interior equals n minus 2 180 over n because it is a regular polygon. So the n value is going to be 18 minus 2 all over, or times 180 all over 18 because my n value is 2. So 18 minus 2 is going to be 16. 16 times 180 is going to be, if I type that in my calculator real quickly, 16, I can just type that all in one. So 16 times 180, press equals, and that's going to give you 2,880. And then in your calculator, without even having to write this down, you could just type out divided by 18, and you should get back the answer of 160 degrees. So that tells me in a regular 18-sided polygon, every single inside angle is going to equal 160. So can we find the exterior angles? So if we were to find the exterior angles, we're going to use, remember, every exterior angle sum is 360 divided by n, which in this example, 360 divided by 18 because we have 18 total sides. So when I type 360 divided by 18 into my calculator, we should get back the number 20. And again, labeling that with degrees. But what do you notice about your interior and your exterior angles? One's 160 and one's 20. Together, they equal 180 degrees. So your interior and exterior angles of regular polygons are always going to be supplementary. That might be something fun to remember. So that way, if I found just the interior angles without having to do any math, well, technically you're doing math, but without having to do any algebra, you could figure out 160. Well, 20 degrees gets me to 180. Then you could tell me right off the bat that the exterior angle is 20 degrees. You have to remember that? No, but you do have to know these formulas. So make sure you get a handle on them. And if you have any questions, to jot those down. If anything is not making sense, again, jot that stuff down so that way we can figure out what's causing you confusion in class. So if we were to go on here, and if you continued watching your video all the way until the very last example, I am willing to offer free assignment or a free, excuse me, not assignment, but a free word of the day for bonus points and maybe even flex time. If you listened all the way until the end of the video and didn't tell your friends, remember to keep this a secret, because if you tell your friends, I will find out. But if you say the word, let's go with monkey. If you say the word monkey, I will give you 3 bonus points on either your next assignment or next learning check. Choose wisely here. And if you share with your friends, if for some reason, I know not everybody in the class will listen to this all the way through, but if for some reason everybody in the class gets this answer, I'm going to count it off. So I wouldn't tell your friends, I wouldn't tell your buddies about the secret word monkey. And again, I'm going to change it because probably a lot of you didn't listen this far. So I'm going to change it to calculator. So if you come tell me the word calculator, when you get into your class and you write down calculator on a sheet of paper and hand it in to me with your name on it, I will give you 3 extra credit points on either your next assignment or your next learning check. Thanks. Thanks for listening all the way to the end. Have a great day.